Hello, and welcome to CEM and Lucidity Systems Wednesday webinars on separation solutions. Today's presentation, Simple and Efficient Solutions for Sample Preparation Analysis, is presented by Dr. Alicia Stell of CEM and Lucidity. Before we get started, let's review some features of GoToWebinar. The audio for this presentation is available on your computer only. If you cannot hear the audio, please check your speaker volume. To access the handouts for this presentation, click the handout icon and then click the handout you want to access. The handout file will automatically start downloading from your default web browser. At the end of the presentation, we will have a question and answer session. You are welcome to submit questions at any time during the presentation. To do this, please type in the question section and click Send to submit your question. Please note, not all questions may be answered live, but they will be answered by email after the webinar concludes. It is my pleasure to welcome Dr. Alicia Stell to this webinar. Dr. Stell has worked with CEM for the past 14 years, joining after completing her PhD in analytical chemistry. Her extensive background in chromatographic analysis and her mechanical expertise have been instrumental in the development of novel systems for sample preparation and analysis. Alicia, over to you.
Welcome to Wednesday webinars on separation solutions. I am excited to get this series started. So before I get into my particular talk, I want to just let you know that I'm going to be covering the instrumentation that CEM and Lucidity offer for separation solutions. Okay, so I don't want you to get worried that I'm not getting too much into the applications and the data because I'm saving that for our guest speakers. So this afternoon, you're going to hear from Dr. Todd Griffin with Griffin & Griffin Associates. And then next Wednesday, you're going to hear from Dr. Rhonda Gross with Dow and Dr. Nick Snow with Seton Hall. Followed by the following Wednesday, where you'll hear from Dr. Jim Grinius with Rowan University and Dr. Emanuela Gianfrido with the University of Toledo. So we've got a stacked group of guest speakers here, and I am super excited to hear what they have to say. So I'm going to let them shine as far as the data and the applications and so forth. And this is just going to kind of give you that introduction to these systems we'll be talking about as we go throughout this webinar series. So the title of my talk is Simple and Efficient Solutions for Sample Preparation and Analysis. I probably start every single one of my presentations with this pie graph. It was in LCGC magazine a few years ago, but I think it's still very true to this very day. And it is staggering that we spend about 62% of our time on sample preparation. In the last few decades, we've made tremendous strides in the area of analysis. And look at that, 4% of our time at this point. That is awesome. But we're still doing a lot of manual techniques when it comes to sample preparation. And sample preparation is obviously very connected to analysis. For good analysis, good sample preparation is needed. Okay, so the fact that I'm going to cover a lot of sample preparation in this talk, but I'm also going to talk a lot about analysis because those two are hand in hand. And yes, that 4%, we've certainly gotten it great as far as time is concerned, but there's certainly some avenues which we'll talk about here today where we can simplify even that aspect as well. So I'm going to cover a little bit on the sample preparation and how we can bring automation and really make that more efficient into that sector, reducing that 62% of our time, but also talk about how we can take that analysis and make it simple. So covering the CEM options for solvent extraction, and again, that pie graph was solvent, sample preparation altogether, right? We're going to talk about solvent extraction particularly, right? Because I could talk about the different amounts of sample preparation. There's hundreds of techniques, right? So we're just going to narrow it down. We're going to specifically talk about solvent extraction. Now, CEM offers well beyond options for solvent extraction, but these ones are the ones that are going to pair really well with the analysis equipment that I'm going to be talking about. Okay, so that's why I've kind of focused in on CEM's solvent extraction options. What we have is our EDGE system, we have a Discover 2.0, and we have our Mars 6. So let's dive a little bit deeper into what those three systems offer. So on the EDGE side of things, that is doing pressurized fluid extraction. Okay, so one of the beautiful things about the EDGE is it's fully automated. You have your sample, and then you can go direct to analysis. The fastest extraction time as well. Total extraction time is 15 minutes. However, it does run in series, so you run 12 samples in series, one right after the other. Our other two options are microwave extraction. On the sequential side, we have our Discover 2.0 system, which for the microwave extraction, you are going to manually add solvent and filter, where the EDGE automates that. Total time for one sample on the Discover 2.0 is approximately 30 minutes. And the Discover 2.0 comes up with an auto sampler that covers 48 samples in series. On the other hand, we have our Mars 6 system. Again, you're going to have to manually add solvent and filter. Total extraction time is going to be about an hour. However, within that hour, you cover a batch of 40 samples. So that's really going to cover your high throughput. And really what we like to say is that they're options that fit your needs, okay? And it's going to depend on application, it's going to depend on the lab, it's going to depend on preference of the user, which one of these is going to fit your needs. But we have a wide variety of options for solvent extraction. And each and every one of these can pair well with the Lucidity analysis systems. Now, I only have a short time today and I'm trying to cover multiple different instrumentations. So I am going to just dig in a little bit deeper into the EDGE to kind of show you how that works in a video. And it really encompasses what we try to do here at CEM, which is taking sample preparation and having options that are faster, smaller, and efficient. Okay, so that faster, smaller, efficient, that's going to apply to everything I'm talking about here today. But we're going to look at specifically the EDGE. So in this video, you're going to see things happen in real time. You're going to see our chemist, Brittany Fessler, come and put in her Q-disc. She dropped that, the Q-disc is doing the filtration. She dropped that into the bottom of our Q-cup, which is our sample holder. That goes together very quickly. It's very light and go directly on an analytical ballot, so you could weigh your sample directly in. The racks are easily interchangeable, so you see that one just slides in right after the other. Once the rack is in and she chooses the method and hits run, then the EDGE is going to take over from there. So you see the EDGE comes down and it's going to grab that sample, that Q-cup, and it's going to put it in that back chamber. That's where the magic happens. That's where the extraction is going to take place. Once it's in that back chamber, the actuator is going to come down and that's going to create a pressurized environment. Okay, so it's sealed. Once that has occurred, now this is a cross section there, okay, so you're seeing that Q-cup, a cross section, what's going on. We're going to add the solvent. The EDGE has 5 different solvent lines, so you can add up to 5 different solvents. Once you have fully wet your sample, you do have the option of bubbling. So the bubbling is just going to add that agitation effect. It adds a little bit, so it's like pressurized fluid extraction with a little bit more. Opens up to doing some dispersive SPE applications. Then we're going to heat and pressurize to a set temperature and or hold time. Once that set temperature or hold time is reached, the sample is then going to drain through the sample, through that Q-disc so it's filtered, and through a cooling coil. So we just were at temperature, and now we're going to collect in at room temperature. And also note, heating is an option and not required. So if you want to run room temperature, that is possible as well. Then we're going to do our rinse. The rinse is just adding clean solvent and immediately collecting it. It just gives you that little bit to get really good recovery values, just rinses everything out. At this point, the extraction is done. Okay, so you can remove the Q-cup. And now we are running in series. We need to be aware of carryover. So we're going to wash that entire fluidic pathway with solvent so that we make sure no carryover is occurring. And then we're going to see the system do that here. That waste, you see that waste bottle on the right in the back there, and you'll see that automation come back there and go to the waste port. And so that needle that just dispensed your sample is being washed. The entire fluidic pathway is washed. At this point, you would move on to your next sample, or you're done. You're going to see Brittany come back over here, grab that rack. And this is just a feel-good moment where you can take that sample that was just wet and look at it, and it's completely dry. So, you know, we've recovered everything, right? We're not leaving anything behind. Of course, we need to look at our recoveries, but just feel good that your sample itself is no longer wet. And we've got a filtered sample ready to go for analysis. So again, I'm not going to spend too much more time at all on the sample preparation techniques, but I hope that gave you just a visual of what CEM brings to the table as far as taking that pie graph that was 62% of our time and minimizing that dramatically, giving your lab automation, traceability, reportability, all these amazing things. So we do sample preparation, right? Now we got to do analysis. And Lucidity Systems offer some great options for some routine analysis that you would do on these samples that we've now extracted. So Lucidity Systems are going to match the results of any GC-FID or LC UV system. Lucidity has 3 products. It has the miniGC, which is a GC-FID. It has a miniLC, which is an LC UV system, and it has the miniGAS, which is a hydrogen and air generator. And you see them all pictured on the cart there. And this is kind of an important aspect because one of the big things about these systems are that they are small and very simple to use, and they open up the possibility of point of need accessibility, right? So we don't like to say portable because you wouldn't bring these into the field. They're standard systems, but they're movable. Right? You can put them on a cart, you can put them in a van. There's really options where you can take them to where you need your analysis to take place. And that really opens up the applicability of these types of systems. So I just want to go through some of the benefits of these routine analysis. Like again, standard GC-FID, standard LCUV. We're not changing the chemistry at all, but we are offering some big benefits. And in that, we've got small size and weight. So we got easy handling. We already talked about that portability or movability. Green analysis, right? There's low power consumption. There's just one standard plug. They're not using as much power because they're smaller. So all of these things are really great. In addition to this small size and weight, particularly for the miniGC, is the fact that that oven is smaller. So you're going to be able to heat it faster. You're going to be able to cool it faster. So in between the time from run to run is actually less time. So there's a little bit of time savings there as well. All of this falling into CEM and Lucidity's passion for smaller, faster, more efficient. Okay, so let's move on with the benefits of these systems. Easy to use. This is probably the most important one to me because it truly does change the market that we can go after with this. We've got simple software, right? It doesn't need to be a trained chemist. Anybody can use it. It's intuitive, right? So anybody can jump up and start running it, and it's probably going to be able to run it. And quick and easy self-installation. So no one has to go and travel and do a bunch of training in the installation. It installs in 30 minutes. 30 minutes, you're up and running and ready to go. And most of that is done via onboard training videos. We're going to be here to assist you if you've got any questions, of course. But what we've really found is this is so simple that it usually is just plug and play. Another big benefit, specifically to the GC-FID, which you saw pictured there, is the column is on this column holder. And it really is like changing a column. It's like putting in a game cartridge. So it's just plug and play from that perspective as well. So anybody can run these systems, really easy to use. So I want to just bring a little bit more to that software. This is just a very quick video where you can kind of watch the mouse going around and see the different things. And right off the bat, this is the front screen, right? And it's just very visual, right? You know where to go, where for my methods, my results, and for my run. So everything's just right there with easy click away. If you watch the video run here, it's just showing you again, you've got all your settings up at the top there, so you always have a quick view of what's going on. Now we've gone into the results. We're going to pick a result and then we're going to analyze that result. and then the chromatogram is going to show up here. So you see all your identified peaks. You labeled your compounds and all your calibration criteria on the method level. So that would all be on the method. You can adjust your integration. You can get concentration values if you had created a calibration curve, and then you're ready to go. You can create a report from there. It really is very simple, and as I noted, intuitive, and it doesn't take a trained chemist to be able to use this particular software. Now, this was done from a GC-FID system, but the software platform is the same, whether it's GC-FID or the LCUV system. Okay, so I've kind of lumped them together because the benefits and the usability are all very similar. So lastly, with the routine analysis with benefits is the fact that these systems are affordable. So what we're finding is that they are accessible to more labs. That our customers are people that probably didn't consider using GC-FID or LCUV chromatography previously. So they were probably outsourcing data, but outsourcing data is becoming very costly and time consuming. And people are looking to bring testing in-house. That's just the reality. And this is opening up the possibility for do that on a very affordable scale. So really anybody currently doing GC-FID or LCUV or outsourcing those types of analysis can consider using these systems. So again, I don't have tons of time, so I'm not going to go over everything with these systems, right? I could talk for each one of the systems I've talked about here today. I could give an entire presentation on. So I'm really kind of just glossing over. And as I noted, there are guest speakers down the road are going to dive into some deeper applications here. But the GC-FID, it does come with an auto sampler. It's a 16-place liquid auto sampler. It can do splitless flow, temperature control from 40 to 400 degrees C, ramps up to 60 degrees C per minute. It can cool from 400 C to 50 degrees C in 5 minutes. You see that's pretty rapid. And it's compatible with 4-inch wound columns. So while your column does need to be on a column holder, you're not limited to the type of columns you can use. So the miniLC has just standard LC specifications as noted. You can use standard columns. The max pressure on the system is 10,000 psi. So you know that as with the different columns and particle sizes and solvents and flow rates, that's all going to affect your final pressure on the system. So whatever is going to work within that 10,000 psi max is what you can run on the system. The flow rates per pump are 0.1 to 10 mils per minute, but again, the most applicable flow rate is going to depend on the pressures and solvents and so forth. And so on average, around 2 mils per minute is kind of going to be an ideal flow rate on this particular system. Has a multi-wavelength UV detector, has a fixed sample loop, an integrated 20-position auto sampler, and then your standard components such as a degasser, a pulse dampener, a static mixer, and a deuterium light source. And the system has a binary pump. So it's a binary system with 2 pumps. And you can see that all on the picture there of the system. The front door is open, so you kind of see into the system, and on the top left, you see your pump heads. And then where you prime them off to the right, you see your column and the column heater there. And then on the left side, beneath the column, you have your flow cell that goes to your detector. And then on the other side, the right side, you have your injector with your fixed loop there. And then on the bottom, you see your 20-place integrated auto sampler. So you have everything that you need here in one small, nice little package. So the final product that I'm going to spend just a little bit time on is the miniGAS from Lucidity. And the miniGAS pairs greatly with the miniGC. It is a hydrogen and high purity air generator, and it creates those gases on demand. So with the miniGAS, you can have the gases that you need to light your FID source, but also has the hydrogen gas you can use as your carrier gas. So it's everything you need. So all you need is DI water, and you're up and running with this particular system. So no tanks needed at all. And I'm going to expand upon that a little bit as we go to the other slides. So here just kind of expands upon that a little bit. For those of you who are running GC-FID currently, probably are well aware that we're dealing with a worldwide helium shortage, and it's not something we're going to be able to make or recover from, right? This is a problem that is here to stay. And with that, helium is going to become more and more expensive, and we're going to have to think of other carrier gases. And hydrogen is a great option. I mean, I think historically, people are just a little bit afraid of it. But with the mini gas, that fear can go away. It's a safe situation where you've got low pressures, on-demand generation, so you're not dealing with a big tank of hydrogen. So it really is green. You know, it's offering all these things we want within this green world that we currently live. All you've got to add is your DI water. And eliminating these tanks is a really big deal, right? And you know, I don't like working with tanks. I don't know who likes working with tanks. And we talk about that movability. Well, with running the tanks, that kind of eliminates that, right? So the mini gas really is what makes these the mini GC portable. And the mini gas included in that box is all the drying agents necessary to deliver the high purity gases. You can see the picture there. It's a very small footprint. There's a liquid level sensor that tells you when it's time to add the DI water. And again, you have lower pressures. So you're running at much lower pressure, so a safer environment. So the mini gas is just really good pairing with the mini GC and falls in with everything we're trying to say here as far as simple and easy to use and efficient. So I'm going to change gears a little bit here, and I've already introduced all of the systems, and I guess I couldn't give a presentation without talking about an application. And so chose cannabis. Todd Griffin's going to be talking a little bit more about this in the second session, so I'm just going to gloss over this here. But cannabis/hemp testing is just a very good example of where CEM can offer a lot of solutions to a particular industry. So you see the list on the left there of all the different types of testing that is typically done within this industry. And CEM can help assist pretty much all of them. Really, we don't do anything with microbiological screening, but beyond that, we've got options for you within this sector. Okay, so this is just a great application because it's so widely versed on the instruments that I'm talking about here today. So I'm using that one. Obviously, the application ranges are kind of sky's the limit. If you're doing analysis or extraction, then probably these systems are applicable in some way. So particularly for the cannabis and cannabis, that was a nice combination of those two words. Hemp and cannabis testing is we've got EDGE, which is again doing solvent extraction, and that's going to be applicable for your potency, pesticides, mycotoxins, terpenes. Okay, so really that's your extraction system. That's what you're using to extract the components that you then need to do analysis for. Now, I introduced the Mars 6 earlier in this presentation as a solvent extraction system, because indeed you can use the Mars 6 for solvent extraction. In this particular case, I would not want to employ microwave extraction because microwave extraction typically happens at a high temperature. And for applications such as potency and pesticides, we really don't want to be running at such a high temperature. So the EDGE, as far as solvent extraction is concerned, is going to be the better technique for this particular industry. But certainly for those higher temperature extractions, microwave extraction is a great option. But the Mars 6 is a great digestion system too. And I haven't really talked about metals here, but I had to throw it in here because it's just a big hot topic right now. There was just an AOAC approved method for microwave digestion for metals analysis in cannabis. So it's very applicable to this industry. And so I'd be remiss if I didn't mention it. Definitely, if for those cannabis labs that are interested in these other systems I'm talking about, certainly there's probably metals analysis going on as well. And the Mars 6 is a great option there. As far as the analysis is concerned, the LC-UV system is great for potency analysis, and that's what I'm going to show you in the data here. And the GC-FID is great for residual solvent and terpenes. Okay, so we've covered a wide variety of different analysis and sample preparation for this particular industry. So what I want to do is just take a quick example of everything you need to do from sample preparation to analysis. In this case, I'm going to compare edge sample preparation to LC-UV analysis of cannabinoids. Okay, so going to walk you through this pretty quickly because, again, I didn't want to get into the nitty-gritty on here for this presentation. This presentation was merely kind of a high-level look. But again, I want you to be able to do what I'm talking about. So the Q-disc, that's going to enable the filtration of your sample. You drop that in first, followed by any sorbent for cleanup if you so desired. I will note that for the data I'm showing you here, no cleanup was deemed necessary, but certainly cleanup is a possibility. You can do in-cell cleanup on the edge. You then add your sample. In this case, we are doing 0.25 grams of a cryo-milled hemp sample. And then lastly, you put in what we call our Q screen. That is just a stainless steel mesh that helps keep the sample down in the solvent. A lot of these samples that we work with float, and that's not going to get the best extraction as they're floating around in there. So we want them compressed and down at the bottom, and that's what that Q screen is going to do. So literally, I always say with this slide, it takes me a whole lot longer to talk through it than it does for me to actually do it. Really, everything comes together in a matter of seconds, and then you drop your cup onto the edge. You saw that video earlier. The edge is going to take care of the extraction, and then your extract at the end is filtered and ready to go to analysis. So the method that we ran for cannabinoids would be a methanol extraction where we added a total of 15 milliliters of solvent. We then heated to 35 degrees C, so very low temperature run, and we held it there for 3 minutes. And then we did that rinse function where you just add more solvent and immediately collect it with an additional 5 mils. So we had a total collection of 20 milliliters of the methanol for this particular extraction. And then we're going to wash. And in this case, we're going to do a pretty aggressive wash because cannabinoids can be present at pretty high levels. And we want to make sure that we have fully cleaned our system for the next wash. So we're going to wash with some isopropanol, which is a good wash solvent. And then we're going to equilibrate the system back with the methanol that we use for our extraction solvent and move on. Everything we talked here is going to be done in under 10 minutes. So within 10 minutes, you're moving on to your next sample. Okay, so we've done our extraction. We have our sample. It's filtered. It's ready to go to analysis. We're going to take it to the miniLC. So when we take it to the miniLC is going to be equipped with a ResTech Raptor column, which is all the specs are noted there. For the data we're showing here, it was a 50 microliter injection with a flow rate of 2 mils per minute. We monitored at 220 nanometers. And the mobile phase was 75% water with 5 millimolar ammonium formate and 0.1% formic acid, and 25% acetonitrile with 0.1% formic acid, and that was an isocratic. So here is some of the results. So when you buy a standard, you get a reference chromatogram. So you see the reference chromatogram there of the cannabinoids. And then you see our chromatogram for the miniLC. They're very comparable, so we're able to determine that we've got good separation of all the cannabinoids within the standard that we were using. And then here are just some of those cannabinoids where we did an edge extraction, and then we compared it back to the hand method, so a typical just methanol solvent extraction as 100% recovery, assume that there, and then you see our recovery values for the different cannabinoids that we were looking at. So overall, great recovery values of the edge compared to the hand method. So again, glossed over this pretty quickly, right? But I just wanted to show you an example where we took CEM sample preparation and paired it with lucidity analysis, and overall got a very fast and simple and efficient process from start to finish. So in summary, I hope I've shown you that CEM has options for solvent extraction that fit your needs, whether it's the Edge, the Discover 2.0, or the Mars 6. And then furthermore, Lucidity has simple analysis options that are small size and weight, easy to use and affordable. And again, that's the miniLC, which is an LCUV system, and the miniGC, which is a GC-FID system that pairs really nicely with that mini gas, which is a hydrogen and high purity air generator. This is another slide that I include in all of my presentations. So I guess I always start the same and end the same. But at CEM and Lucidity, we really pride ourselves that we are where you are. Okay, and as a small company, we are able to do that, to offer great customer service. We have an amazing sales, support, and application teams that are going to be able to assist you throughout your journey, whether it's on the sample prep side of things or on the analysis side of things. So definitely, again, don't hesitate to reach out after this presentation, or if you've got any questions, we're here to assist you, and just like to bring home that message. So I need to thank my team. They are the people that make this happen. Okay, I couldn't present anything that I have here today without them. They are the stars in this all. So you've got on the organic support team, you've got myself, who's the product manager, our senior scientist, Candace Cashman, our product specialist, Brittany Fessler, our application scientist, Benedict Liu. And then on the Lucidity side of things, you have their president, Mike Collins, and their R&D scientist, Daniel Iverson. So no matter who you're talking to on this list of people, they're going to be able to answer your questions and get you the information you need. And it's just a huge shout out to them. And also, you can always email organic.support@cem.com whether you got questions, regardless of the systems I talked about here today, any of those systems. Reach out to that email address. You're going to get one of the people pictured here, so it's putting a face to the name there, and we're going to be able to assist you. So I thank you for listening here today. Again, this is the kickoff to the Wednesday webinars on separation solutions, and hopefully I got everybody excited of what's to come. And again, mine's just the introduction. I am excited on what's to come as these guest speakers, Dr. Todd Griffin, Dr. Rhonda Gross, Dr. Nicholas Snow, Dr. Jim Grenius, and Dr. Emanuela Gianfrino. Okay, so awesome stacked group of people. Can't wait to hear their presentations. So tune in as this webinar series continues today and for the next 2 Wednesdays to follow. Take care. Reach out to organic.support@cem.com with any questions. And I'm going to be in the question and answer session for all of the webinar series here. So if you got any instrumentation related questions, please do not hesitate regardless of the session that you're listening to. So with that, I thank you and have a good day. Bye.
Thank you, Alicia. That was a very informative presentation. We will now begin our question and answer session. As a reminder, to submit a question, please type it in the space provided and click Send to submit.
All right, well, it looks like we do have a few questions coming in. Alicia, the first question is, can you tell more about the Q-disc?
Yeah, I definitely can. And this is a situation where, again, I wasn't getting into all the details because it wasn't a edge specific presentation. But yeah, it's a great question on what we're used to do our filtration. Leanne, just want to confirm that you can hear me just fine because my computer just muted me again and I unmuted.
Yep, mine was the same way. I don't know what's going on, but I can hear you now. Sorry about that.
Okay. So I apologize for that. But yes, so our Q-disc, which does the filtration, we have a universal Q-disc we recommend, which is our S1. That is a stack of Q-disc. At the heart of that stack of Q-disc is our G1 filter, which is a glass fiber filter that filters down to 0.3 microns. So the G1's doing the work. It's what's going to enable you to go direct to UPLC analysis if that is what you chose to do. And but if you've ever worked with glass fiber, it is not very robust, right? You can kind of pull it to get apart really easily, and we're running in a pressurized environment. So to maintain the robustness of that G1 filter, we put it in a sandwich of C9 filters. Our C9 filter is a cellulose filter that is a 40 micron porosity. So again, the cellulose filter is not doing the filtration, the glass fiber is. They come pre-stacked together in our packaging, so simply you got to just pick one up, drop it in, and you're good to go. Again, it takes just seconds, but yes, you're going to get 0.3 micron filtration with our recommended Q-disc, and that is for any application, whether you're doing cannabis, which was discussed here, or you're doing any sort of food application, environmental application, polymer application, we'd recommend the same Q-disc.
Okay, great, thank you. And when would you choose the Discover over the Mars 6 for microwave digestion, or I'm sorry, microwave extraction?
Yeah, of course, yeah. So that's one of the things that we're just kind of now talking about, right? Historically, the Mars 6 would be what we really talked about as far as microwave digestion, or I'm even saying digestion now, microwave extraction is concerned. There's an EPA method out there, EPA 3546 for soil, semi-volatile organic compounds in soils. So that's a very approved and widely used method. But the Discover 2.0 really is going to come into throughput. So the Mars 6 is that batch system, high throughput, going to be really good for those environmental testing labs that are dealing with hundreds of samples per day. Where the Discover is going to be more on the R&D side, not as much throughput, but you just need immediate results. So you need to basically drop a sample in, get that extraction quickly, and then drop in so you can make decisions on what to do moving forward. It's particularly really good for the polymer industry where you're using smaller sample sizes and you need a good stirring. The Discover 2.0 has great stirring, which lends itself to things like polymer samples. So really throughput is the main thing, but as I noted with that stirring aspect, that brings in some advantages on the Discover 2.0 as well.
Oh, okay. Thank you for that clarification. Our next question is, can you tell me more about the Lucidity software?
Yep. And this is one thing that I am just really excited about, is because typically when you're running a GC or an LC system, software is quite complex, right? Really takes a lot to kind of learn that software. Probably is going to require training, and can be a little bit daunting, maybe overwhelming when you jump in. Certainly not one that is intuitive, where you kind of jump in onto one of these softwares and you know exactly how to do everything you want to do. The Lucidity software is really easy to use, right? It was designed with the user and usability in mind. It's very pictorial. You saw in that video there where you just can choose what you want. It is intuitive, right? Someone who has had no training could probably step up and figure out how to run it just because it is, straightforward and not complex. So it really is a huge advantage to these particular systems. And another great thing is the software comes with the purchase. You're not having to, it's not an additional thing that you have to get. And also I can send you, if you were interested in, hey, I want to demo that software, I want to see what you're talking about here, I can send you that. You can download it on your own personal computer and play around with it and see how truly easy it is to run. So that's a huge benefit too, is that it's just so easy to say, here, yeah, try it, see what I'm talking about, how it really is. Anybody can run it.
Wow, okay, great, thank you. Can you tell me more about what columns you can use on the miniGC?
Yeah, another good question, because I think right off the bat, when you look, okay, I've got to use a column holder, you immediately think, oh, I'm going to be roped into using a certain column, right? And that brings out a certain concern or fear for that customer, because they want to use the columns that they've always used and not be limited in any way, shape, or form. And so I really want to, first off, say, okay, yeah, it has to use a column holder, but we can easily get that on the column holder for you in any column that you request. There are some minor limitations, like on basically 60 meters or below for fused silica and or metal capillary columns. So if you really wanted to go maybe a 100-meter column, that may be a little bit of a challenge for us, but most really any standard column that you would want to use up to 60 meters is going to be able to be wound at the proper diameter so that it fits on our column holder. The way it's installed on the column holder, standard ferrules and connections, okay? So it's the same components you're used to working with. So it's not like we're changing the connections or anything there either. Anybody who can change out a column should be able to do so on this as well, as far as loading it onto the column holder. And another great thing is usually when you're, changing a column in a GC, your head's in that oven, you're trying to, it might be a little bit awkward to get to that port. This can be done on the bench top, so it's right there in front of you. So if anything, it might be even easier to initially install the column onto the column holder. Once it's on the column holder, it's literally seconds. It just plugs in and out. It's like putting in a game cartridge.
Oh, okay. Well, thank you for that. All right, our next question is your pesticide extraction set up based on an EPA approved method?
So yes. Usually I don't think EPA and specifically think pesticides, because when I think pesticides, my head goes more to the food industry and thinking more of a catcher's-like application that would be the most common one. But certainly pesticides are under the semi-volatile organic compounds list as well. And there is an EPA method, 3545A, which is for pressurized fluid extraction, which the EDGE adheres to for the extraction of semi-volatile organic compounds. So certainly the EDGE is applicable to an EPA method. And I just mentioned that the microwave extraction in a previous question is also connected to an EPA method, 3546. So yes, whichever technique we're talking about here today from the extraction side does adhere to an EPA approved method.
Okay, thank you very much. Our next question, how long does it take to install a miniGC with a mini gas?
Okay, so I kind of tout about 30 minutes, and that's for both, combination of both systems, because the mini gas certainly doesn't add a lot of complexity there. And just to kind of talk you through this process, this is a self-installation. So we're able to send these systems to you. As noted, they're very small, so you can pick them up, right? So you don't have to, you could come in a box, you pick them up onto the desktop, you connect your lines, and then once you've got all of with the mini gas, right, that's going to provide your carrier gas as well as your gases that you need to light your FID. So the only thing you need to have on site is some DI water. You pour a little bit of DI water into that mini gas, you power everything up. You are going to want to verify the calibration on your auto sampler, but that's going to take just minutes. And then we send a test mix. So you have a test mix that then you're going to shoot onto the GC and make sure that that matches the results of the test mix when we ran it before we shipped the system. And that's kind of your qualifier. So once you've run your test mix, you qualified the system, then you're good to go. And doing this entire process from start to finish, so literally box to you have a qualified, verified system, takes about 30 minutes.
Wow, that is very fast. All right, next question. Does the miniLC have an auto sampler? And if so, how many positions?
Yeah, so when you look at the miniGC, you immediately see, if you choose an auto sampler, you see that auto sampler sitting on top of it, right? So the miniGC has an additional auto sampler that sits on top of it. That's a 16-place system. Now, if you're looking at the miniLC, you're like, well, I don't see an auto sampler there. I just see a box. And that's because the auto sampler on the miniLC is integrated. Okay, so when you open up that front panel, then you're going to see the auto sampler down at the bottom, and that is a 20-place auto sampler that comes integrated in with the LC system. So with the LC, literally out of the box, onto the table, add in your solvents that you're using for your mobile phase and for washing, and you're good to go.
Okay, excellent. Next question is, what would be the main applications on the Lucidity systems?
Yeah, so kind of, talked about that as far as sky's the limit on the applications, right? Really, if you can, if it's applicable to LCUV and or GC-FID, then you're going to be able to do it on these systems, because these systems are standard systems. We're not changing the chemistry at all. But what we're seeing as we kind of look into, the industry here, we're seeing a really big pull within academia. You'll notice a lot of our guest speakers to come are professors, and they're really seeing, this ability to bring GC and LC analysis to students that would normally, they wouldn't be able to have that opportunity. So the academic industry is really big. And then I mentioned the cannabis industry in my presentation. We're seeing that as a really big pull as well. And then flavor and fragrance. We're seeing how there's a lot of smaller companies that would typically be outsourcing that data, and kind of like I noted, they're now having that opportunity to bring that testing in-house because these systems are so easy and straightforward and affordable. So I'd kind of put flavor and fragrance as another big top as far as the applications are concerned. But we could go on and on and on, but I'd say academics, cannabis, and flavor and fragrance are probably where I'm seeing as the top 3 right now.
All right. Very interesting. Well, Alicia, this was a great question and answer session. I think we have managed to answer everything that's come in. So at this point in time, if there are no further questions, we will end this presentation. I do want to thank everyone for attending today and for the great questions that you asked. And we look forward to seeing everyone at 3 o'clock this afternoon for Todd Griffin's presentation of detection and quantification of THC isomers in cannabis-infused edibles. So gosh, it sounds like that'll go right along with your initial presentation, Alicia. So thank you everyone for attending, and we look forward to seeing you at 3 o'clock.
Thank you. Take care.